All right, let's do a handful of examples here, shall we? Example 1. So when we see this symbol here, without its little limits of integration, we know that it just means to anti-differentiate from the antiderivative. So you can either read it as, find the antiderivative of 10x to the fourth minus 2 secant squared x with respect to x, or find the indefinite integral of, and then, so on. Okay, so it just means, of course, to find the antiderivative. So I'm going to increase the power by 1. I'd have 10x to the fifth over 5. Of course, you could probably do that division in your head, reduce that to a 2, minus, okay, so what function's derivative is secant squared? It's tangent, of course, so 2 comes along for the ride, so -2 tangent x. Now we don't put the little such that with the limits of integration, simply because we don't have any. It's not a definite integral. It is an indefinite integral, otherwise known as an antiderivative. So you put a plus c here, and essentially this is a function. Actually, it is an infinite number of functions that you could graph, like, whoa, no, hey, that's the wrong button, thusly, right? And that plus c being visually represented by the fact that you would have, a whole bunch of vertically translated functions. Here, let's take a look at another one. On example 2, finds antiderivative of x plus 1 over the square root of x with respect to x. Okay, so I definitely want you to keep in mind that there is no antiderivative rules for quotients. So what that means is whenever you get a quotient, you're probably going to have to rewrite it in some kind of a way, right? All right, so we can do that by perhaps turning this into x to the 1/2 power and then just dividing it into both of those terms. If this thing was flipped, the reciprocal, it'd be a little bit more difficult to do, and you'd probably have to do some sort of division. Hey, we're not there yet. Okay, so anyway, rewrite this as the antiderivative of x plus 1 over x to the 1/2 power, still with respect to x, okay? And then, like I said, just divide this term by term here. So x divided by x to the 1/2 is x to the 1/2. And then you would have 1 over x to the 1/2, but I'm going to rewrite that with a negative exponent, x to the negative 1/2 power. And now term by term, use the power rule on it. So I would have x to the 3/2, adding 1 to it, divided by 3/2. When you divide by a fraction, it's the same thing as multiplying by the reciprocal, so it's 2/3 up front. And then plus x to the, if I add 1 to negative 1/2 gives me positive 1/2, divided by positive 1/2, again, multiplied by the reciprocal, it's a 2 up front, and then don't forget your little plus c business there, and that's pretty much done. I mean, you could do some fancy factoring, but whenever you have little plus c here, we usually don't. I mean, you could turn it back into, let's say, radical notation, because that's what it began with. If it's a multiple choice question, just look at your answers for a clue as to what move to make next. Let's look at one more of these. Example 3, we have yet another quotient. What does that mean? Does it mean we're going to have to rewrite this? Of course it does. We have sine divided by cosine squared x. Okay, so I need to rewrite this in a form that is an antiderivative that we know, because that's all we have is just general antiderivative rules. We haven't learned any tricks yet. That's the next lesson coming up. It's on substitution, where we can start to solve some much more complex integrals. Okay, but here we have to turn it into something that we can easily recognize. So maybe, I'll give you a little clue here. If I break this up like this, sine x over cosine x, right? Maybe that helped. I don't know. Maybe I break it up one more time. This is like on the bottom here, I have cosine, cosine. I can make this 2 fractions, sine over cosine, and then the other one would be 1 over cosine. Hey, what's sine over cosine? I'm pretty sure it's tangent. And then 1 over cosine is secant. And then one last thing, and that is to find the antiderivative because we're ready. What function's derivative is tangent secant, or, secant tangent? It is secant x. Don't forget plus c. So again, you could take the derivative of this guy and you would get secant tangent and you'd be good to go. All right, in the next one, I'm going to do something super special for you. I'm going to show you how to do some of this stuff on the calculator. And by some, I mean, only specifically the definite integrals. This stuff we can't, not without a computer algebra system. So you're relying upon you, your brain, and your brain's ability to remember all of your anti-differentiation rules.